Okay, so this is a kind of work example of a Venn diagram problem. So in this case, we have 50 soccer fans, and they're asked which of the 3 soccer matches A, B, and C they saw over a given weekend. And you're given some information that 5 have been to all 3 matches, and then 16 have been to both A and B. And the idea is to draw a Venn diagram to incorporate all this information in a kind of visual manner, because actually having it in sentences is not always very clear. And okay, so let's do that on the next slide. Okay, so I'm going to read out from the text. So the first part is we draw a Venn diagram, have this big box of the universe. I put in circles A, B, and C, and they have intersecting bits. And then it's a question just converting the text into the diagram. So 5 said they'd seen all 3 matches. That goes in the intersection of all 3 circles. This is the 5 here, which is the A and B, C circles intersect. 16 has seen both A and B, so that's the 16, it goes in here. 15 has seen both B and C, that goes there. Okay, and then there's some stuff here. 23 had seen match C, and a total of 25 had seen match A. It's not clear how to do that, so we'll just keep that in mind. And then we had 2 people who didn't go to see any matches at all. Okay, so you can kind of see that what happens here. We don't have information on the number of people who just went to match A. We don't have any information on the number of people who went to match A and C. And we don't have any information on the people who went to see match C, just match C on its own. Okay, so the question says how many people have seen match B, and from that you can just read directly off the diagram. It's going to be 8 plus 16 plus 5 plus 15, which I wrote on the first sheet. So we have enough information to do that. But then the next question is how many people have seen both match A and match C, and that requires determining this X, right? And that, so we don't have enough information at the moment to actually determine without a bit of calculation. Okay, so because it's maths, I've introduced some variables. I don't know how many people went to see A, I'm called that Y. The number of people who went to see A and C, I'm going to call that X. And the number of people who just went to see C, match C, I'm going to call that Z. And then obviously we have some information. It wasn't directly clear how to convert that into a Venn diagram. We had 23 people had seen match C, and 25 people had seen match A. And so then we can set up a little equation. So we know that 23 people had seen match C. And if here, from the Venn diagram, we can introduce variables. So then we have X plus 5 plus 15 plus Z equals 23. So that uses that information. Then we can set up another equation for the number of people who've seen match A, and that's Y plus X plus 16 plus 5, and we're given information that's 25. And you can kind of start to see that we've ended up with 2 equations for X, Y, and Z. Okay, so we've got 2 equations. We have a bit more information. We've got the fact that there are 50 fans. And what that means is that all these numbers and all these boxes should add up to 50. So that's what this equation here is down at the bottom. This is the universe. And this tells us that if I add in Y plus 16 plus 5 plus X plus Z plus 15 plus 8 plus the 2 who didn't go to any matches, that has all got to equal to 50. Right, so now I've got 3 equations, and the question is just grinding through. They've been a bit, normally that's a bit involved, but here they've been a bit nice to you. So I'm going to simplify the equations. So I have the equation C, A, and U, U's for the universe. And I have 5 plus 15. So on the next slide, I'm just going to convert it into X plus Z equals 3. Here you see the simplification. You have 16 plus 5, which is 24. So you're going to have Y plus X equals 4. And then when I add up all the arithmetic here, we'll have another equation, U. Okay, so when we want to fill in this Venn diagram, just recall So we're trying to find these numbers here, y, x, and z. Okay, so we set up the three equations from the number of people who went to see games A and C and total number of people. I now have the equation x plus z equals 3, x plus y equals 4, x plus y plus z equals 4. And we need to solve for x, y, and c. Here the numbers work out quite nicely. So here I have x plus y equals 4. Here I have x plus y plus z equals 4. So I'm going to substitute x plus y equals 4 into here. This is what I do here, x plus y plus z equals 4. X plus y equals 4. 4 here plus z equals 4 implies z equals 0. Right, so they've been a bit kind for you here, because so z equals 0. From the first equation, you can then do x plus z, z0 equals 3. This tells us that x equals 3. And now you know that x is 3 and z equals 0. You can plug that into here, x plus y plus z equals 4. And if I've not made any mistakes, I substitute x equals 3, y is what we're looking for, z is 0, equals 4. This gives me y equals 1. And then we can kind of populate our diagram. We have all the information here. So now we have the number of people who, well, this is part 3. The number of people who went to see A on its own is 1, which is part 3. How many people went to see both matches A and C, not B, which is going to be 3. Okay. So I mean that might be a bit fast. So the basic idea is here, we're given some basic information. If you know what a Venn diagram is, you can kind of identify all these things, and then you have to do a bit of manipulations to convert the 25 people who've seen match C, the 25 people who've seen match A, and the fact there's 50 fans overall. You had to use that to convert those into equations, and then once you had that, you can do a bit of simple a bit of manipulation to determine what the x, y, and z is. And once you've done that, you've ended up with a standard Venn diagram, and then you can kind of answer the questions by reading off the different part of the circles or where they intersect. So the key part is converting all the information into a format you can put on the Venn diagram.